Hello and welcome back to Higher Maths Integration. Today in lesson 3 we're going to look at undoing the chain rule. So if we remember from the differentiation chapter, if we are differentiating bracket to the power n, we bring the power to the front, we get n multiplied by bracket to the n minus 1 because we need to reduce the power by 1. We then multiply by the derivative of the bracket. So in this case, the derivative of this bracket is just a. So we're going to end up with an bracket ax plus b to the power n minus 1. So again, power to the front, reduce the power by 1, multiply by the derivative of the bracket. So we're going to undo that in this lesson 3. So we need to add 1 to the power, so the integral of bracket to the n. If we have ax plus b in the bracket, this only works for ax plus b in the bracket. So add 1 to the power, divide by the new power. Now, when we differentiate up here, remember we need to multiply by the derivative of the bracket, which is where the a is coming from. So when we're undoing that, we also need to divide by the derivative of the bracket. Okay? So we're not just dividing by n plus 1, we are dividing by a multiplied by n plus 1. And again, why are we doing that? Because if we differentiate this, we'll get n plus 1 bracket to the n, so the n plus 1s will cancel, multiplied by the derivative of the bracket, which will be a, so the a's will cancel there. And of course, add on the constant of integration afterwards. Okay, so let's look at a few examples. And again, we're just undoing the chain rule. So the integral of bracket to the 7, so add 1 to the power, divide by the new power, and also divide by the derivative of the bracket, which in this case is just 1. So it'll be bracket to the 8 all over 8 plus c. Number 2, bracket squared. So add 1 to the power, divide by the new power. We are also dividing by the derivative of the bracket. So we also need to divide by 2. So bracket cubed over 6 plus c. Now let's differentiate that. So that'll be 3 bracket squared multiplied by the derivative of the bracket, which is 2. So 3 2s are 6. Divided by this 6 is 1. That would get us back to 2x plus 3 all squared. Question number 3. Exactly the same idea. What is this bit about? This is because we cannot divide by 0, so we need this in here to be mathematically correct, for the question to be mathematically correct. So if we substituted negative 9/5 in here, we would get 0. We can't divide by 0. Okay, so we just need this statement in the question. Essentially, you can just ignore it. Okay, so integrate this with respect to x. So it's the cube root, so it'll be bracket to the third. Can't integrate with that as the denominator, so bring it up to the numerator, so it'll be bracket to the negative 1/3. So add 1 to the power. Negative 1/3 plus a whole. Negative 1/3 plus 3/3 is 2/3. Divide by the new power, which is 2/3. And we also need to multiply by the derivative of the bracket, so it'll be 5 multiplied by 2/3. So we have bracket to the 2/3 over 10/3. If we're dividing by 10/3, we are multiplying by 3/10. So I've written down here. And again, back into root format or surd format. Top number is the power, bottom number is the root. So it'll be the cube root of bracket squared, all multiplied by 3/10. And of course, plus our constant of integration. And last question, 7 over 2 bracket to the 5. So again, the bracket comes up, the 2 stays down there. So 7 bracket to the negative 5 over 2. Add 1 to the power, divide by the new power. We've already got a 2 on the denominator, guys, so that stays where it is. Also need to multiply by the derivative of the bracket, which will be negative 3. So we have 7/24 bracket to the negative 4 plus c. And again, we started off with a positive index, so just move the bracket to the negative 4 down onto the denominator. 7/24 bracket to the 4 plus c.